Session is on part C, the applications. First one says, a bakery makes a mixed dozen selection of bread rolls. Of the 12 rolls, 2 are poppy seed, 2 are wholemeal, 3 are white, 4 are multigrain, and 1 is Cape seed. What fraction of the rolls are white? So what we have to do first is work out our denominator, and we know our denominator is always the total amount. So how many bread rolls do we have in total? Well, they actually tell us of the 12 rolls. So 2 plus 2 plus 3 plus 4 plus 1 should give us the 12. So that will be my denominator. And then what fraction of the rolls are white? Well, how many white ones are there? There's 3. So we have 3/12. And then we simplify our fraction. So divide by 3, we end up with 1/4. So 1/4 of the rolls are white. What percentage of the rolls are wholemeal? So now we can first work out our fraction and then turn it into a percentage. So once again, we have something out of 12, and wholemeal, where's wholemeal? 2 are wholemeal. So 2/12 are wholemeal. And then I'll divide by 2. It's best to simplify it next. And now that we know to turn anything into a percentage, we have to times it by 100. So I'm going to times this by 100 or 100%, and that's 100 over 1. Now I can simplify before I multiply. So I can divide by 2 and divide by 2, so halve it. So now I've got 1/3 times 50 over 1, and then we end up with 50 divided by 3 or over 3. And don't forget that's a percentage. Now, in real life, we don't, that's not much use to us. It's an improper fraction. We want to turn it into a mixed number. So I'm going to leave it in fraction form. If you wanted to divide this and get a decimal, you could as well. But I'm just going to, Now, because 50 is getting larger, you could still use an algorithm to help you work out the remainder. So 50 can go in there, 3 out there. I'm not going to add any zeros because I'm going to leave it in fraction form. So 3 into 5 can go once, remainder 2. 3 into 20, that's 20 there. So 3 into 20, I know 3 times 6 is 18. So that's 6 times, and that remainder would be 2. So I just wrote the remainder there. So as a fraction, so remember the remainder goes on our denominator or the divisor if it's in this form. So our final answer, I'll just squeeze it here, will be a big 16 and then 2 over 3, so 2/3, and don't forget the percentage symbol. Okay, and there we go. And if you had it as a decimal, that's fine as well. What fraction of the rolls are poppy seed or multigrain or Cape seed? All right, so this is where we still have the same denominator. There's still 12 rolls in total, but we've got to combine some and add some up. So poppy seed, there are 2 from what the question said. Multigrain, there are 4. And Cape seed, there's 1. So 2 plus 4 plus 1 would be 7. And 7/12 are that combination. The local council advertises that their public pool contains 2% chlorine. If there are 5,000 litres in the pool, if there are 5,000 litres in the pool, how many litres of chlorine are there? Okay, so we obviously know a pool is full of water as well. So there's 5,000 litres of water. So what percentage, or how many litres of chlorine is there? So if there's 2%, so we're finding 2% of the total is 5,000. So first understand how to, what the question's asking, okay? Sort of, it's like it's asking a fraction of something, but we've got the percentage. Now we know percentage is just a fraction, so that's really 2 out of 100, okay? Of becomes times, and 5,000, I can write it as 5,000 over 1. All right. And now I'm going to simplify before I multiply. It looks like I can just cancel 2 zeros from the bottom, and I can cancel 2 zeros from the top. That leaves me with, now on the bottom is just 1 times 1, which is going to be 1. So I don't have to write 1 on the bottom. So on top, I'm left with 2 times 50. 2 times 50 is 100. Now, always put units in and answer the question. So explain what 100 means. That means there's 100 litres. So 100 litres of chlorine in there. Okay, it's a real life problem, so always try and answer the question, explain what your result is. Okay, here on a farm, half of the animals are sheep. So we've got half a sheep. Now, write equivalent fractions to show how many sheep per total number of animals there could be on the farm. Well, basically, we can write any fraction as long as it represents a half. So, for example, if I've got 200 sheep on the farm, if I've got 200 animals in total on the farm, and it says half of the animals are sheep, that means 100 are sheep. If I've got, you can pick any number. If I've got 20 animals on the farm, that means 10 are sheep. If I have 6 animals on the farm, that means 3 are sheep. And these are all equivalent fractions. They are all half. And you can keep going. Now, I've got 3 there. That should be enough. Now, if there are 800 animals, how many would be sheep? So if the total was 800, well, what's half of 800? There would be 400. So 400 would be sheep. So 400 are sheep. Now, next one. Which value is larger? Explain why. All right, so we've got 0.8 of a pizza, 70% of a pizza, or 3/4 of a pizza. Now, you can see that they're showing the values. One's a decimal, one's a percentage, one's a fraction. In order to compare these properly, it's best to pick one. We can pick a percentage, we can pick a decimal. I think a percentage would be the best way to go to compare. So this is already 70%. I'm going to turn the others into a percentage. To turn 0.8 into a percentage, all I got to do is times by 100 and add the percentage symbol. So that times 100 will leave me with, so 1, 2. So I would get 80% for that one. So now I've got 80%, 70%. Now 3/4, I know 3/4 is 0.75. But if you didn't know that, you can just times it by 100 as well and use your fraction skills. So I could divide by 4 here, divide by 4. That will become 1. That will become 25. And I'm left with 3 times 25. And don't forget, it's still a percentage. And 3 times 25, I'll just write it over here so we can compare, is 75%. Now they are all percentages. I can compare these much easier. So which value is larger? Well, the 80%. So A would be larger. And if you explain why, well, we can say the 80% is a larger percentage because we converted them all to percentages. All right, next one. Now on this page, we have a table and it says Jack measured some pencils and then sharpened them, making them 1/10 shorter. Fill in the following table that will show the new length of each pencil. So new length, that's important, of each pencil as a decimal and a fraction. So they want the decimal here and then as a fraction here. All right, now you have to understand, if we're making something 1/10 shorter, we have to work out, I'll just use this paper here, some more space. We're basically working out what is 1/10 of something. So our first number is 11.6 centimeters. So what is 1/10 of 11.6? Now this is going to happen with all of them. Well, 1/10 of becomes times, and 11.6 is over 1. So I end up with 1 times 11.6 over 10. Now, when I say over 10, we know this means division. So we end up with 11.6 divided by 10. And that's really easy to work out. So whenever you have 1/10 of something or 1 on top and a number on the bottom, you're dividing by that bottom number. That's a trick. So dividing by 10, a power of 10 is easy. 1 0 means we go back 1 spot. Or the decimal goes back. So we end up with 1.16. Now, that is not the length of the new pencil. That's 1/10 shorter. 1.16 centimeters would be 1/10. So I want to I'll write it here. So we got 1.16. So that means I want to make it 1.16 centimeters shorter. So this is where you have to go 11.6, take away 1.16. Now, you can set up an algorithm if you can't do that mentally. If you want to add a 0 at the end, it looks like it's sort of like 60, take away 16, if that helps. But I'll set up an algorithm over here. So I've got 11.6 take away 1.16. Yep. So setting up an algorithm is the best way to go. Line up your decimals. You can put a 0 in this spot if there's empty spots. And let's go. 0 take away 6 I can't do. So I take from the 6 and it becomes a 1 there. So 10. 10 take away 6 is 4. 5 take away 1 is 4. 1 take away 1 is 0. And 1 take away nothing is 1. So I've got 10.44. So this would equal 10.44. That's the new length of the pencil. So I made it 1/10 shorter. That's 1/10 and I subtracted it from that. Now to turn that into a fraction, that's really easy. 10.44 would be a big 10. It's going to be a mixed number. And 44 over, there's 2 decimal places, so we need 2 zeros. And there's my fraction. Now I can simplify the fraction part, this to 44 and 100. I can divide them both by 2. I could also divide them both by 4. So I'm going to think of the highest factor. So divide by 4 and divide by 4. And I'm left with, I'll just squeeze it here. So a big 10 is still there. All right, so 44 divided by 4 is 11. And 100 divided by 4, I know there's 4 25s in 100. So 25. So as a fraction, and I'll put centimeters, that's our units. So that's 10 and 11 over 25 is the fraction part. All right, so for all of these, you first have to work out what is 1/10 of each of these measurements and subtract it from the total. So we can do the 1/10 part quickly. So all of these, we're going to divide by 10 to find 1/10. And I explain why with the first example. So go back one. So 1/10 would be 2.07, 0.985. Go back one. So 2.065 and 1.418. So you got to subtract all those measurements from the total length of the pencil and then write it in there. So I'll leave you guys to do that one. And yeah, same process. Now over here, we've got the sum of 2a and 2b. So we've got to write an algebraic expression. So these ones will have no equal signs. Expressions have no equal signs. So we'll have 2a plus 3b. That sum means addition. So we know that keyword is sum plus. 8 less than 5a. So remember 5a comes first and 8 less than that. So make sure 5a was first, take away 8. The double of 6x. Now to double something, we got to times it by 2. So 2 times 6x. If you had that, that's great. You could even have it like this, 2 bracket 6x, because we want the times to be invisible. Now, if you even multiplied it, 2 times 6 is 12 and got 12x, that's also correct. The difference between x and y. We know the difference relates to subtraction. We can use subtraction to find the difference of any values. So it would be x take away y. 2/3 of x. So of we know is times. So 2/3 of, instead of writing of, I'm going to put times x. And don't forget x is on top of a 1. Now I'm going to simplify that. So I've got 2 times x on top, which is 2x over 3 times 1 is 3. Okay, so 2x over 3. Number 2. So write an algebraic expression for the following. So expression again, 9 times the number n minus 3. So 9 times n will be 9n minus 3. The sum of 3x and 56. So sum again is plus, so 3x plus 56. The sum of 2l, 5m, and 3n. So 2l plus 5m plus 3n. The product of 3x and 6y. So we have 3x times 6y. Product means the answer we're multiplying two things, I guess, or multiplying. And then we've got 3 times 6 is 18xy. The average of 4a and 8a. So average is, to find the average, we add up what we have. We've got 2 things, and the 2 things will also be my denominator. So what I mean is, I'll just squeeze it here. So because I'm adding 2 things, 2 is on the bottom, And on top, I add them up. So 4A plus 8A on top. Sorry, a bit squished in there. Okay. So the average is you add up all your numbers, your values. So we've got 4A plus 8A. And because there's 2 in total, the 2 is my denominator. We divide it. Next one. If X represents any number, write an algebraic expression for the following. All right, they want us to use X instead of N. So 9 times the number X plus 5. So 9X plus 5. 1/5 of the number. So remember, of is times. And 1/5 is 1 over 5. And the number is going to be X. And then minus 7. So let's do it. So 1/5 of is times X. So X over 1. And then minus 7. Now I'm going to fix this up. We don't want to have a times there. So let's simplify this part. So 1 times X is X on top. 5 times 1 is 5 on the bottom. And the minus 7 can just sit out there. And we're done. The sum of the number and 15. So the number they want us to use is X. The number and 15. So plus 15. Sum is addition. The difference, so take away again, between the number and 9. So we can do X take away 9. And the last one here, 5 more than the number. 5 more than, so X is first, and then 5 more than that. 5 more than the number. So make sure X was first. All right, so we've done that page. And the last bit of our applications is this page here. All right, so what does it say? In a room, there are K people and 5 people leave. How many people are now in the room? So we started with K people. K represents, we don't know how many people there are, but they're represented by K. If 5 leave, well, we subtract 5. So it'll be C as our best option or only option. B, Nicholas buys 10 lolly bags from a supermarket. If there are 7 lollies in each bag, how many lollies does he buy in total? Well, they tell us there's 10 lollies in a bag, so that'll be 10 times 7. And 10 times 7 will be 70 lollies in total. So 70 lollies in total. Now with B, they say there are N lollies in each bag. So this time they haven't told us how many lollies in a bag, but they want us to, so there are N lollies in each bag. How many lollies does he buy in total? So for this case, we can't actually work it out, but what we can do is write an expression. So same process, N lollies, could be 7, could be, I don't know, any number, in each bag. And there, don't forget there's 10 lolly bags. So N times 10, and we can simplify that to 10N. So there are 10 N lollies in a bag. If N was just say 5, it'll be 10 times 5, which is 50, but we don't know what N is. Now, you have a job at KFC. You get paid $10 every hour you work. How much will you get paid if you work 2 hours? All right, well, if it's $10 every hour, I can go 10 times 2, which is going to be $20. How much will you get paid if you worked 4 hours? Same thing. If I get paid $10 an hour and I work 4 hours, what's 10 times 4? That's $40. Right, now, this is an equation, so this has to have an equal sign. Write an equation that you can use to calculate your pay depending on how many hours you work. All right, so we can start off by writing it as a sort of like a sentence, I guess, using words. So pay, now we have to have an equal sign. So my pay is equal to $10 every hour. So I can leave the dollar sign for now. $10 every hour. Now I know to work this out, I've been using multiplication. So I'm going to replace every with times. And that's pretty much our equation. But because in maths, and to keep it more simple, rather than using words, let's use just a pronumeral. I'm going to have, instead of pay, the word pay, I'm going to use P for pay equals. Now I don't have to have the dollar sign there. I'm just going to write 10. Now instead of writing times, I'm going to keep that invisible. And for hour, I'm going to use H. So I end up with this. P equals 10H. Pay is equal to $10 times every hour. And that's it. Now, if your boss gave you a $20 bonus, add this to your equation and write your new equation below. Well, that's easy. I've got P equals 10H, and I've got to add the $20 that I got as a bonus. So that plus 20 is separate. It's a constant. It happens just this one time, I guess. So for that shift, if I work 5 hours, I can go 10 times 5 plus the extra $20. And the last one for the applications is this one. The length of the line segment shown could be expressed as we've got A plus 3 plus A plus 1. So this line segment, there's a chunk that's A and 3 and A and 1. Now we don't know what A is. A is obviously an equal length, but they haven't told us just yet. So write the length as a simplified expression. All right, so we've got to add up the A's and the constants. So A plus A would be 3A, and then 3 plus 1, still positive, so plus 3 plus 1 is 4. So 3A plus 4 is that simplified version. And B, what is the length of the segment if A is equal to 5? So now we can use substitution. If A is 5, you can use either one, the equivalent expressions. I'm just going to use this one. So 3 times A, so 3 times 5 plus 4 will give me the length. And 3 times 5 is 15. 15 plus 4 is 19. Now, they haven't given us units. They haven't said if it's centimeters or meters. So we'll just put 19 units. Just write units. And that's it for applications.